Hello there, welcome to this tutorial on trigonometric equation. This tutorial is brought to you by Digital Mathematician. In this video, we will look at this problem. Given that 0 degrees less than or equal to x less than or equal to 360 degrees and sine x minus cos 2x is equal to 0, find the values of x. So we are going to get not just one value of x, but as many as possible within the range 0 degrees to 360 degrees. So we start the solution of the problem. Sine x minus cos 2x is equal to 0. We are going to look at identities involving cos 2x that will contain purely sine x to substitute for cos 2x. We look at the identity for cos 2x using a double angle formulae. So that's going to give us cos squared x minus sine squared x. This is also equal to 2 cos squared x minus 1, and the third one is 1 minus 2 sine square x. So these are the identities for cos 2x using double angle formulae. So the one that will fit in here that contains purely sine x is the third one, which is this. So we are going to substitute that one into the equation, so that we now have sine x minus 1, that is in bracket, minus 2 sine squared x is equal to 0. We expand, that's going to give us sine x minus 1 plus 2 sine squared x is equal to 0. This minus multiplied by this minus gives a plus. So we arrange this equation in descending power of sine x. So we are going to have it as 2 sine squared x plus sine x minus 1 is equal to 0. So what we do now is we let m be equal to sine x, so that we now substitute into the equation to have 2m squared plus m minus 1 is equal to 0. I have a quadratic equation now. So by factorization, we are going to have 2m minus 1 into m plus 1 is equal to 0. If you factorize this 2m squared plus m minus 1, that's what you are going to have. So solving this equation, I'm going to have m is equal to 1 over 2 and m is equal to negative 1. So since we already substituted m to be equal to sine x, we substitute back. So we now have sine x is equal to 1 over 2, then sine x is equal to negative 1. So from here we take it one after the other. That is for sine x is equal to 1 over 2. We are going to look at trigonometric ratio of the general angles. So we have it here. Sine x is positive here, so it is going to be in the first quadrant and the second quadrant. So in this case, we now look at x is equal to sine inverse of 1 over 2, and for the first quadrant it is going to be 30 degrees, and in the second quadrant it is going to be 180 minus x, which is equal to 150 degrees. That is for sine x is equal to 1 over 2. Then for the second option, which is this, for sine x is equal to -1. We are going to have it in the third and fourth quadrant since sin x is negative there. What we'll do is, to get x, we omit this negative sign. We are going to have it as sine inverse of 1. We are not using -1, so keep it. This is just going to help us to get the actual value of x, and that's going to give us 90 degrees. And this is our x now that we are going to use here. We are going to use here, and we are going to use here. To do that, in the third quadrant, the actual value of x now will be 180 degrees plus 90 degrees, and that will give us 270 degrees. Even if we come here to say 360 minus 90 degrees, will still give us 270. So the value of x equal to 270 degrees is taken care of in the third and fourth quadrant. Then we now look at the values of x. We have it here, here, and here to be 30 degrees, 150 degrees, and 270 degrees. And remember, we said this particular value of x is just meant to be used to get the values in the third and fourth quadrant. So that's all for the solution of this problem, and this is the end of this tutorial. Thank you for watching. I hope you enjoyed it. Please like and share this video. Also remember to subscribe to our YouTube channel, Digital Mathematician. Until we come your way again, goodbye.